Okay, so hopefully you can see my periodic table okay, but whenever we're doing electron configuration, this periodic table is going to be our best friend. So just as a reminder, our group 1 and group 2, this is our S block. And then over here where we have 13 through 18, this is our P block. And then everything down here in the middle is going to be our D block. They correspond with the orbitals that the electrons are residing in. So let's take a moment and let's try to do, let's say we want to figure out the electron configuration of beryllium. So beryllium, let me show the periodic table back again. Beryllium is over here and it's in row 2, and we always want to start up here at hydrogen. So over here we have hydrogen, 1, 2, so that is 1s, 1s2, because that is row 1 of the S block, and there are 2 electrons because we did hydrogen and helium. Now we're going to move over to the next row, and we're in row 2. We're still in that S block. We go 1, 2, and then we've reached beryllium, S2. So this would be the electron configuration of beryllium. Now your professor might also ask you to do the electron diagram of your atoms, which is just showcases the electrons and their spin. So let's take beryllium again, for example. We have 1s and then 2s. I'm only drawing one line because remember that they act in pairs. So our electrons come from our exponents up here at the top. And remember that electrons don't like to be next to each other, right? So here, we're going to draw an upwards arrow and then a downwards arrow. And that is these 2 electrons up here. Over here, we have 2 more electrons inside my 2s orbital. So again, I'm going to draw one up and one down. So this would be the electron diagram or the orbital diagram of beryllium. But let's look at another element, maybe one that goes all the way into the P block. So let's take nitrogen. Nitrogen is all the way over here, so we're going to go through 1s2, 2s2, and then we're in 2p, 1, 2, 3. 1s2, this is hydrogen and helium. 2s2, this is lithium and beryllium. And then 2p, let's double check that again. 1, 2, 3. 3. Whenever you're doing electron configuration, you're kind of reading the periodic table like a book, and then you just stop whenever you get to the electron or the atom that you're looking for. So this would be the electron configuration of nitrogen. So now the orbital diagram would look something like this. We have a line for 1s, a line for 2s. Now, the P block can hold up to 6 electrons. So I have 1 P orbital, so I'm going to do 3 lines. And remember that each line can hold up to a pair of electrons. So this is my 2p orbital. So let's start over here. We have 2 electrons inside 1s. So I'm going to have one up and one down. Over here, I have 2s, so I'm going to have 1 electron up, 1 electron down. Now when it gets to 3p or 2p, what a lot of people do at first is they go up, down, and then they go up again. This is wrong because again, electrons, they like to be spread out inside the orbital as far apart as they can. So instead, what happens is we have 1 electron spinning up over here, we have another electron spinning up over here, and then we have another electron spinning up in this direction. This way, they have as little contact as possible, and they're nice and spread out. I've only got 3 electrons, so I'm only going to have 3 electrons or 3 arrows here in my 2p. Okay, let's try another one. Okay, let's do, which one should we do? Let's do iron. So the D block is real funky. Everything about the D block is weird. It acts weird. I'll show you what I mean when we get to there. So if we're going all the way to iron, okay, so we have we go through 1s2 because of hydrogen and helium, 2s2 because of lithium and beryllium, 2s2, and then we get to the P block, 2p, 1, 2, 3, 4, 5, 6, 2p6, then we're here at 3s2, 3s2, okay, and then we get back to the P block, 3p, 1, 2, 3, 4, 5, 6, 3p6, okay, hopefully you can see that with the glare. Now we're down here at 4, so 4s2. Now, the D block is a little weird. The row number isn't the same as it is with the S block and the P block. What I mean by that is over here, technically we are in row 4, but you can kind of think as if the D block accidentally slid down a row. So even though it says 4 for the D block and the D block alone, I'm going to subtract 1. So instead of going to 4D, we're going to do 3D. Okay, hopefully you can see that okay. And then the D block can hold up to 10 electron pairs, or 10 electrons. So let's go ahead and count. 1, 2, 3, 4, 5, 6. So then I'm going to do 3D6. And that would be my electron configuration for iron. So here's how the orbital diagram is going to look. One line for 1s, one line for 2s, 3 lines for 2p, one line for 3s. I'm going to go down here. And then 1, 2, 3 lines for 3p. And then the D block, since it can hold up to 10 electrons, I'm going to do 5 lines because that's 5 pairs. 2, 3, 4, 5. Oh, I skipped 4s. One line for 4s. And then 1, 2, 3, 4, 5 for 3D. Okay. Let's do yellow for our electrons. Okay. So putting in our electrons, again, we have upwards arrow, downwards arrow, upwards, downwards. Same thing with P, so we go up, 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 and then down, 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 okay? For 3s, we have 1 up, 1 down. For 3p, fill it in again, up, up, up. I still got 3 more, so down, down, down. 4s. Now for 3D, we have 6, so we're going to go 1, 2, 3, 4, 5, and then with that last electron, it gets paired up here, just like that. So that would be the electron configuration of iron. Hopefully this video helps. I can make some more on, like if you need noble gas electron configuration, it's very much the same way. It's just kind of like a little bit of a shortcut so you don't have to go through all of this. Just let me know if you need one specifically for noble gas electron configuration.